there's, like when when I was going through school being a bio major and that sort of thing, I also did a minor in chemistry, which means everybody would say, oh no, chemistry is more important. Oh no, bio is more important. Chemistry, bio, chemistry, bio. I'll let y'all know now, nothing exists without chemistry. Chemistry is the most important. That's the level we're going to start out with. The chemistry leads us to the organelles that we mentioned of the cell, which give us a cell. Cells make up tissues. Tissues make up organs. Organs make up organ systems. Finally, we get to the organism. That's as far as we go in this course. That's not the end, though, of the levels. When you look at the organs of the body, this is what we get. This is what the cells and the tissues are making up. They're making up the brain. They're making up the liver. They're making up the intestines, the bladder, all these different things that make the human organism. For the most part, for part 1, we're going to make it through skeletal system, muscular system, and we're going to hit a little bit on the nervous system. There's a lot left over, isn't it? Yes. That's going to be left for part 2. But our biggest goal, because if you think about the organ systems, we're going to look at tissues, which are made up of the cells. We're going to have to kind of change our way of thinking a little bit. We're going to look at the skin, which is the largest organ of the body, okay? And then we're going to start moving into the skeletal system, muscular system, nervous system, and then you'll finish up the rest of it in part 2. So when we talk about the organ systems of the body, we have our integumentary, which is the skin, our skeletal system, our muscular system, the lymphatic system. Some people refer to this also as the immune system, but the lymphatic, our respiratory, the digestive, nervous, endocrine, cardiovascular, urinary, female, male, reproductive. That's the point that your textbook will end. Your textbook will end with the male reproductive system. So that's a lot of systems to actually work your way through to get to the end of the textbook. If we're dealing with human organisms that are going to have this level, that level, this level, this level, do you guys remember talking about the characteristics of life? A little bit? Okay. What's important about this? For something to be considered alive, it has to possess every characteristic. For something to be considered alive, it has to possess all of these characteristics. There needs to be organization, metabolism, responsiveness, growth, development, reproduction. As a human, do we meet all of these characteristics? Am I concerned about it as a whole? What level am I concerned about? My cellular level. Does an individual cell of our body possess every characteristic? Yes, it does. Every cell of my body is organized. It carries out metabolism, meaning it has to get and use energy. It has the ability to be responsive. It grows, it develops, and reproduces. Think about that for a second. This is at the smallest part of the human. This is telling me kidney cell, liver cell, stomach cell, muscle cell, nerve cell, everything is carrying out every characteristic of life. If it didn't, something is wrong. Something is wrong at the cellular level. Something is wrong with the organism as a whole. Yes, no, maybe. Yes. Now, biomedical research. Heard of that before? When did it start?
When HIV came out? No. Back in the Dark Ages with the plague?
Even before then.
I guess when we started, it's discovered different things all the time. It's like,
Ever since man has had the ability to think, all right? Note my terminology here. Ever since man has had the ability to think, they have been curious about the human body. That understanding has come a long way, okay? And we can do research, and we have learned that a lot of things can be representative from studying cells. So a lot of what we do is at the cellular level, all right? But a lot of things are done at the organism level. Now, in early days, think about like up until roughly mid-1900s, okay, which I don't know if any of y'all are familiar with that time frame, but up until roughly the mid-1900s, they still did medical research on humans that was definitely unethical, okay? Now, does that mean that it was not important? Yes, it was, okay? We learned a lot. However, with ethics now, we have to be a little careful. Some people will sign a release, for example, if they're getting ready to have surgery, so that they can study what's happening. For example, brain surgery, all right? They're like, okay, we're going to cut the top of your head off and root around in there with a stick, all right? But if you think about it, that's one of the organs we know the least amount of information about. We are studying it every day. We learn new information every day. One of the things that helps is when they do surgery, people sign a release so that they can take a peek, so to speak, okay? Before we had ethics, they would just simply cut the top of the head off and root around in there with a stick, all right? Didn't matter what the outcome was, okay? I mean, we've come a long way, but one of the ways that we still learn a lot is by the study of actually opening the human body up. Okay? That's why if I ever have to have anything done, okay, for example, when I had my knee surgery, okay, I was like, the doctor knew the entire time leading up to the surgery that I'm an anatomy and physiology teacher. You don't get to just open up my knee and I not see it. Okay? So, get up to the day of surgery. He knows he's supposed to have the DVD set up and the recorder and all of this other stuff. So he comes in, does, I'm in there for a little pre-op stuff and everything. I'm like, you got the recorder ready? Oh, no. You're not touching my knee until you get the recorder set up. And sure enough, they went and got it set up, and I've got the surgery of my knee, Of course, I don't have a DVD player anymore, to be able to see it on my computer. But I did get to see it before that. So anything that has to be done, I'm like, oh, no, I got to see this too. You got to give me the pictures, give me the video. I want to know, okay? Now, our body, as a whole, like I said, we are extremely organized, very organized, all right? And I will probably talk about stuff and say some stuff as we go through the course, and it's going to give away my age, okay? I do not look my age. I'm proud of that, okay? But I'm going to give away my age. This term is one of the ways that I'm going to give away my age, okay? Because I cannot mention homeostasis and not think of biodome. And some of you in here don't even know what that is, all right? I'm like, I never thought I would get to be this old, okay? But here I am. I'm this age, all right? Homeostasis, maintaining our internal environment. We tend to think of this term for the individual as a whole. Guess what? What level do I want you to think about it? Cellular. Y'all are doing excellent. Cellular level. Because if it has all the hierarchy, if it has the characteristics of life, why wouldn't the cell have homeostasis? As a whole, why is homeostasis important to an organism?
Because it regulates the body, like the body's chemistry.
Okay, so chemistry, let's think about that for a second. If chemistry was that first level of the chemicals leads to the making of a cell, to the point of it functioning, to it building proteins, okay? So, how can it be effective? How can homeostasis be effective?
Say, for instance, blood pressure.
Okay, blood pressure.
The baroreceptors, the veins tells the pressure's too high or too low, which tells the brain, hey, look, I need tell the heart to pump more
or less.
Right. Or body temperature.
Body temperature. That's one that's pretty easy to talk about. But think back to your general bio class, okay? And you're just beginning to learn about the organelles of the cell. You're learning about the nucleus. You're learning about DNA. You're learning about genes. You're learning about transcription and translation, because the only thing that a cell can produce is what?
Protein.
A protein. Proteins are very, very special. How can they be affected? They probably taught y'all this in your bio.
If there's a change in the protein, it may or may not function the way it's supposed to.
Because structure determines function. For a protein, structure determines function. One of the biggest factors of our body that will affect proteins is body temperature. Y'all will soon learn that when I say they, okay, that means some people who sat in a room, took some information and go, okay, this is our average. Okay, that's who I mean when I say they, okay? So they have told us the average or the optimum for us as a human is 98.6. Anybody in here have a constant 98.6 temperature? Some people run higher, some people run lower, okay? That is our average. The goal for that 98.6 being the optimum is because that is the optimum temperature that proteins can function. You take that temperature too high. For example, y'all been seeing all the stuff in the news about this flu strain going around, and the hospitals are filling up and all this sort of stuff, okay? What's one thing that the flu might do?
Give me a fever.
Give you a fever. It will take your temperature up. Now, to a certain point, leave it alone. Let your temperature go up. All right? That's your body's way. That's the immune system. That is our system trying to clear itself of the problem. Okay? But if the temperature goes a little too high, then yeah, you need to start getting concerned. Take some of the Tylenol, Motrin, whatever the case might be. If it doesn't go down, keeps going up, well then, take a shot to the hospital. Okay? Once it gets to a certain point. All right? Why?
Because it's certain.
Things won't function properly if it consistently stays high or even stays too low.
Your body will actually shut down and see
You might be
too high of a temperature.
You can't process proteins at a higher temperature.
My proteins are going to get denatured. Proteins carry out every function of the body. If I denature my proteins, I've affected their structure. If I have affected their structure, I have affected their function. And if too much of that happens, things are not going to work right, especially the brain. Our brain is extremely delicate, very well protected, okay, but extremely delicate. High temperature is going to denature proteins. Basically, your brain's going to fry. So, you need to make sure that you don't let that happen. All right? But now, wait a minute. All fine and good because we've talked about temperature going up. Can temperatures go down?
Yes.
Yes. Is that important too?
Yes.
Yes. Because, once again, the optimum temperature, 98.6, for the functioning of those proteins. You take it down, it's going to affect their function just like taking it up. Luckily, our body in this brain has an area that's extremely primitive. Do you know what area of the brain that is? Brainstem. Now, that area, when I say primitive, I mean primitive. It is controlling the body functions that keep you alive. It has this, just the structure, the way it works, everything about it is totally amazing, all right? And it has the ability to monitor the temperature. And by monitoring the temperature, it has the ability to make other things happen in your body so that it can stay at roughly the 98.6. For example, temperature goes up too high, you're going to sweat. Whoa, what? Wait a minute. Huh? What system just got mostly affected from the simple fact my temperature went too high? Which of those systems that we just listed? Look back. Take a peek. Take a peek at the systems. My cardiovascular system. Yeah. There you go. I love getting that look right there. Because, think about that. Something that's going to do to help, fix my temperature, my cardiovascular. What? How does that happen? What makes you sweat?
Like when you're exercising and you're like,
Sure. Yeah.
Or like the heat.
What happens?
Your heart starts to like kind of race faster.
Yeah, well, if we're exercising,
It dilates the vessels near the skin.
vessels at the skin dilate, and the heat in the blood gets pushed out. But then, wait a minute. What happens if I get too...
They dilate. Kind of constrict. Keep the heat in.
They're going to constrict. And in all reality, where are we focusing? What part of the body?
The heart brain.
My core, my brain, and my major organs. The job is to keep them at 98.6. And if I got to cool things off, I'm going to push that blood to the skin, get the heat out, and if I need to warm it up, I'm going to pull that blood back to these organs, and guess what? I don't care if your fingers freeze and drop off. I don't care if your ear freezes and drops. I don't care if your nose freezes and drops off. I don't care. I'm keeping the core warm. This is what happens in frostbite. All that cold we just had, and get the little alerts on my phone, about the weather and that sort of thing. And it was like, temperature is extremely dangerous, dropping down to 5 below zero. Frostbite can occur within 30 minutes. And I'm thinking, yeah, that's really going to probably be happening. Just like when everything started warming back up, okay, and I go to the grocery store and I'm like, somebody is going to be in shorts. I'm thinking that as I'm going down the aisles of the grocery store, and I look up, and what do I see?